Okay, this is picking up after we had did 0 and 5, and now we're at 15, and we're going to do 20 eventually, okay? All right, so we're going to put in 15. We're going to put in 15 milliliters. That would be 0.015 liters. That is then multiplied by 0.15 molarity. That gives us the moles of NaOH. And that's going to be 0.00225 moles of NaOH. So that's going to take away 0.0225 of my acid. That leaves 0.00075 moles of acetic acid left over, and that also adds 0.00225 of the acetate ion. We're going to solve for hydrogen ions like we did the other ones. So basically you're going to have, we're going to use the Henderson-Hasselbalch equation that we went over on Thursday. And to do that, you would go ahead and say the pH is equal to the pKa plus the log of the A minus over the HA concentration. Okay, so the pKa would be the log of the Ka. And when we log the Ka, that's going to give us 4.74. So that translates into pH is equal to 4.74 plus, and then the A minus would be 0.00225. And that would be divided by 0.00075. And then that would give us our pH. And you can use a Henderson-Hasselbalch equation anytime you've got anions and a certain concentration and the acid of a certain concentration. That would be 5.22. So after 15 milliliters, the solution should read 5.22. Okay, so now what we're going to do is also show you, I'm going to make a copy of this. We will not use this top equation much to do this next part. But we'll kind of get it to show you where we're at in the process. So now we're going to add 20. So we're going to add 20 milliliters. What that does, basically, when you go ahead and refigure the number of ions that transfer over, instead of 15, we've got 20 milliliters times that. So it'd be 20 or 0.02 liters of 20 milliliters to cancel that. That gives you 0.003 moles of NaOH. At that point, we call that an equivalent point, where we have equal OHs and Hs that are balanced out. So we have afterwards, we had originally 0.003, we're going to minus 0.003, and that gives us 0. Acid remains. So there's no more acid that remains. But this was added 0.0030 moles. So we have 0.003 moles, but we don't have any acid. So no longer can we go through, it's no longer the buffered solution because there's no more acid. There's only the acetate ion. So we have to revert back to this concept that we'd already have studied. It's just like if we have 0.003 moles of acetate ions, and if we want to find the volume or the concentration of those ions, we take 0.003 moles, divide it by the volume that we added. And if you remember, we started with 10 milliliters of acid. So that's a total of 30 milliliters. The 20 that we added of the base and the 10 of the acid. So that's a total of 0.030 liters. And so the acetate ion concentration, we need to have that to do this next part, because no longer can we use the Henderson-Hasselbalch equation because we don't have any acid remaining. So then we find out that concentration, and we find out it's 0.1 molarity of the acetate ions. So if we want to find the pH of it, then we have to transition to this. And what we do is we go C2H3O2. That's going to act like a base. It's going to react with water. It's going to make hydroxide ions. And we're going to make also, we're going to get some of those acetic acid molecules back. So again, we have initial. The initial is the concentration of ions. We can't do moles anymore. We have to have the concentration to set it up correctly. So this is 0.1 molarity now, is where we're at. The OHs would be 0. Acetate ions would be 0. The change is minus X, plus X, plus X. At equilibrium, we have 0.1 molarity minus X, X, X. Okay, so what we're going to do, this here, we're going to have to find a Kb for. The Ka of acetic acid is equal to 1.8 times 10 to the minus 5th. What we're going to do is we've got to find the Kb. To find the Kb, it's going to equal Kw over Ka. Kw is 1 times 10 to the minus 14. Ka is 1.8 times 10 to the minus fifth. When you do that calculation, that gives you the Kb. And that's what you're going to need to use in which to figure OH concentration. And that's 5.6 to the minus 10. And that's of your acetate ion, which would be your conjugate base of the acid. So then when you solve for X, you're going to go ahead you're going to take 0.10 molarity minus X. This is X squared. So then you take 0.1 molarity times 5.6 times 10 to the minus 10th, and you get 5.6 times 10 to the minus 11 equals X squared. Take the square root. That gives you X, which is the same as OH concentrations. Okay? When you do that, you get 7.48 to the minus 6. That's your OH concentration. If I log that number, take the minus log of that number, it gives me 5.12. So if I take the minus log of that number, I get the POH. And that's 5.12. The pH I find by taking 5, subtracting it from 14. And so when I do that, the pH is 8.87. So after adding 20 milliliters, now this is 8.87 is what it is. Okay? So the first one, we just went ahead and solved for X without having anything in of a weak acid. When we added 5, 10, and 15, we used the Henderson-Hasselbalch equation where we figured out the moles of acetate and the anion of, or the acetate ion and acetic acid. And then when we reach the equivalent point, we no longer can use that, and so we'll have to switch our equation around and take the acetate ion, react it with the water that's in there. It's going to have more OHs and H's, and we'll solve for those OHs like we did, solving for X. When we solve for X, that gave us a number that would have been 7.48 to the minus 6. That would have been the OH concentration. If you would take the negative log of that, you get 5.12, which is the POH. And then you get the POH, or get the pH, you take 14, subtract 5.12, and you get the pH. Okay. Now, we'll stop there, and then on Monday, we'll talk about what if you go over that, where now it's basic. Okay? Well, it's basic now, but let's say that we add extra OH ions, then at that point, we don't have to really set up the equation. We'll do it a little bit different because now we've got our only strong strong base in there. It's just hydroxide ions, and you figure that a different way as well. So we'll wait till Friday or Monday to do that.